At 7:46 in the evening on Friday, July 31st, 2026, the ground west of Naples shook harder than it has since scientists started continuously measuring it there at all. A magnitude 4.7 earthquake, centered between the towns of Pozzuoli and Quarto, injured at least 21 people, 2 critically. It suspended rail service across the entire Naples network. It shut the port of Pozzuoli, cutting ferry service to 2 islands in the middle of peak tourist season. This wasn't a random earthquake. It struck inside Campi Flegrei, a volcanic caldera so large that from the ground you can't actually see its edges. And this specific earthquake broke a record for the 3rd time in just over a year. Here's the part that's actually drawing scientific attention right now, though. A new mathematical analysis of this caldera's behavior claims its unrest doesn't just keep breaking records. It claims the pattern itself has shifted into a category almost never confirmed in an active volcano before a euro, one where the acceleration is itself accelerating, pointing toward a specific window in the early 2030s, when something, mathematically, has to give. What does that actually mean? And what doesn't it mean? Let's find out exactly what's happening beneath Naples. Before we go further, if you want volcano science explained with precision instead of panic, subscribe to Earth Anatomy. Every week, we break down the hidden physical systems shaping our planet Euro tectonics, oceans, atmosphere Euro, using verified research instead of viral headlines. Drop a comment and tell us, had you heard of Campi Flegrei before this video, or only its more famous neighbour, Vesuvius? Now, let's find out exactly what's happening beneath Naples and why. Let's establish the timeline first, because this earthquake didn't appear out of nowhere Euro. It's the latest entry in a pattern that's been building and repeatedly breaking its own records for more than 2 years. Campi Flegrei has been in an active state of unrest since 2005, when the ground beneath the town of Pozzuoli Euro, sitting at the caldera's centre Euro, began rising in a process volcanologists call bradyseism, from the Greek for slow movement. Since then, Pozzuoli's town centre has risen by more than a metre, accompanied by increasing earthquake activity and elevated gas emissions from the caldera's fumarole fields. This isn't this caldera's first bradyseismic episode Euro. We'll examine its earlier crises and why they matter for understanding the current one in Part 5 Euro. But the current episode has been accelerating in a way that's drawn increasing international attention. On May 20th, 2024, a magnitude 4.4 earthquake struck Campi Flegrei Euro at the time, according to INGV volcanologist Giuseppe Di Natale, the strongest ever recorded in the area's history. Hundreds of residents were forced to sleep in tents or cars. A women's prison near Naples was evacuated as a precaution. About a dozen apartment buildings were emptied for structural checks, displacing roughly 40 families. Less than a year later, on May 13th, 2025, a magnitude 4.4 earthquake struck again, this time as part of a swarm that produced 49 separate registered seismic events within about a day. Italy's civil protection minister, Nello Musumeci, formally declared a state of emergency for the Campi Flegrei area Euro, a designation specifically intended to accelerate ongoing risk mitigation work, rather than an announcement that an eruption was imminent. Later that year, 2 separate magnitude 4.6 earthquakes struck the region, each one, in turn, becoming the new record for the area's strongest instrumentally recorded event, which brings us to this past Friday. At 7:46 p.m. local time, a magnitude 4.7 earthquake struck at a depth of roughly 3 kilometers, with its epicenter between Pozzuoli and the nearby town of Quarto Euro, very close to the Solfatara crater, a site we'll examine closely in Part 2. Italy's National Institute of Geophysics and Volcanology, universally known by its acronym INGV, confirmed this as the strongest tremor recorded in the area since continuous instrumental monitoring began Euro, surpassing both of 2025's magnitude 4.6 events, which had themselves surpassed 2024's record-setting magnitude 4.4. The human and infrastructural toll from Friday's earthquake was immediate and serious. At least 21 people were injured, 2 of them seriously. Some regional reports placed the figure as high as 26. Emergency crews evacuated roughly 250 people from Pozzuoli in the earthquake's immediate aftermath. As building inspectors fanned out across the area in the hours that followed, at least 9 structures were formally declared unsafe, with somewhere between 18 and roughly 290 residents a euro, depending on which specific inspection wave is being counted a euro, ordered out of their homes. A number of officials expected to keep climbing as checks continued. Falling rocks and debris struck parked cars and railway tracks. Regional rail service across the entire Naples network was suspended. The port of Pozzuoli was closed entirely, severing ferry service to the islands of Procida and Ischia during the height of Italy's summer tourist season. More than 60 aftershocks followed through the night. As this investigation is being compiled, in the immediate aftermath of Friday's record-breaking earthquake, these figures should be understood as a flaw. Not a final count euro inspections were continuing, and the numbers were still expected to move. Here's what makes this specific moment different from Campi Flegrei's prior record-breaking earthquakes, though, and it's the reason this video's title makes the specific claim it does. Alongside this real, physical, headline-making earthquake record, a separate and genuinely novel piece of scientific analysis has begun circulating. A mathematical re-examination of the caldera's entire pattern of unrest since 2005, arguing that Campi Flegrei's seismicity and ground deformation aren't merely accelerating a euro, they're accelerating in a way that itself keeps speeding up. A specific, formally defined mathematical signature that researchers say has essentially never been confirmed before in an active volcanic system anywhere on Earth. That analysis identifies a specific window, centered on the years 2030 to 2034, as a point where the current mathematical pattern itself can no longer continue a euro, where something, in the researcher's own careful words, has to give. This is where this investigation needs to draw a very careful, very deliberate line, because it's exactly the line this video's title sits on top of. A literal instrumental record a euro, strongest earthquake since monitoring began a euro, is a real, verifiable, entirely ordinary kind of fact, the sort that gets broken and rebroken as any monitored system generates more data over time. A claim that a physical system's underlying mathematical behavior has shifted into an almost unprecedented category is a genuinely different, far more significant kind of claim a euro, and one that deserves to be handled with real scientific care rather than treated as instantly, self-evidently confirmed. Before we can properly evaluate what that mathematical claim does and doesn't mean, we need the basic vocabulary of what Campi Flegrei actually is, how bradyseism works, and how scientists have monitored this specific caldera for decades. That foundational science is where we turn next. To understand both this week's earthquake and the more unusual mathematical claims circulating alongside it, we need to build up the basic vocabulary of what Campi Flegrei actually is a euro, because it doesn't look or behave like the volcano most people picture when they hear the word. Most people imagining a volcano picture a single, cone-shaped mountain a euro, Vesuvius, sitting just 15 kilometers away on the other side of Naples, is a textbook example. Campi Flegrei is structurally different. It's a caldera, a broad, low-relief depression roughly 12 to 13 kilometers across, formed not by a single mountain building upward, but by the ground itself collapsing downward and inward following 2 enormous prehistoric eruptions. From ground level, standing inside it, you genuinely cannot see its full outline a euro. Much of the caldera's western half sits under the town of Pozzuoli and the western suburbs of Naples, while the rest extends offshore, submerged beneath the Bay of Pozzuoli. Those 2 prehistoric eruptions are worth understanding in their own right, because their scale sets the baseline for why this caldera is taken so seriously today. The larger of the 2, called the Campanian ignimbrite, erupted approximately 39,000 years ago, and is considered the most powerful known explosive eruption in Europe over the past 200,000 years a euro, classified at magnitude 7.2 on the volcanic scale used for the very largest eruptions, ejecting somewhere in the range of 180 to 300 cubic kilometers of material and depositing measurable ash across a huge swath of Eastern Europe. A second, considerably smaller caldera-forming eruption called the Neapolitan Yellow Tuff followed roughly 15,000 years ago, producing the distinctive yellow volcanic stone still visible throughout Naples' older buildings today. Since then, geologists have documented more than 70 additional, smaller eruptions inside the caldera, grouped into 3 broader eruptive periods. The most recent of all of them, and the only eruption in this caldera's fully recorded historical era, produced a small cinder cone called Monte Nuovo in 1538 Euro. An event we'll return to directly in Part 5, because its own specific timeline carries real, practical lessons for how quickly this caldera can move from unrest to actual eruption. Now let's turn to bradyseism itself, the specific phenomenon defining Campi Flegrei's current, decades-long episode of unrest. As magma, and the pressurized fluids and gases associated with it, shift beneath the caldera, the ground surface directly above can rise or fall a euro, sometimes by meters, over years or decades, sometimes more rapidly, over weeks or months. This isn't a new or exotic process unique to the current crisis. It's been documented at Campi Flegrei for thousands of years. The clearest historical evidence sits in plain sight at an ancient Roman market called the Macellum, sometimes known as the Temple of Serapis. Its surviving marble columns bear a distinctive band of boring marks left by a specific species of marine mollusk, roughly 6 to 7 meters up from their base Euro physical, datable proof that this exact spot sank low enough to be submerged in seawater for centuries, before rising again to stand dry, well above sea level, as it does today. Bradyseism, in other words, is a documented, recurring, centuries-old feature of this specific landscape, not a novel phenomenon invented to describe the current unrest. The current episode began in 2005, and it has been genuinely persistent. The ground at Pozzuoli's centre has risen by more than a metre since then, with the rate of that rise generally increasing over the past several years rather than levelling off. This uplift is typically accompanied, as we saw directly in Part 1, by increasing earthquake frequency and elevated gas emissions from the caldera's fumarole fields Euro, most notably at Solfatara, an ancient volcanic crater within the caldera that still actively vents steam and gas, and the nearby Pisciarelli fumarole field, both of which sit close to Friday's earthquake epicenter, and both of which we'll examine as direct monitoring sites in Part 4. Now let's introduce the specific institutional and technical vocabulary this investigation will rely on throughout. Italy's National Institute of Geophysics and Volcanology, INGV, operates a dedicated Vesuvius observatory responsible for continuously monitoring both Vesuvius and Campi Flegrei Euro, two of the most closely watched volcanic systems on Earth, sitting just 15 kilometers apart, together threatening a metropolitan population numbering in the millions. INGV assigns each monitored volcano a formal alert level using a 4-tier color system. Green, indicating quiet, background conditions. Yellow, meaning attention Euro, heightened unrest, requiring closer monitoring, but not indicating imminent eruption. Orange, meaning pre-alarm Euro conditions, suggesting evacuation preparation is warranted. And red, alarm, reserved for conditions indicating an eruption is considered imminent. As of this investigation's most recent data, Campi Flegrei sits at yellow Euro, a designation that has remained unchanged even as the earthquake record described in Part 1 has continued to be broken. To track the specific data feeding into that alert level determination, INGV relies on several complementary types of instruments. Continuous GNSS Euro, Global Navigation Satellite System Eurostations, functionally similar to high-precision GPS, track ground deformation to millimeter-level accuracy at fixed points across the caldera. One station in particular, designated right, sits near the center of the deforming area and serves as a key long-term reference point for tracking the uplift discussed above. Seismic networks record and catalog every detectable earthquake, however small, allowing scientists to track not just individual events, but the statistical character of the entire ongoing sequence Euro, a concept called cumulative Benioff strain, which adds up the energy released by every recorded earthquake over time into a single running total, making it possible to spot acceleration or deceleration in the sequence as a whole, rather than simply counting individual events one at a time. And geochemical monitoring teams periodically sample gas and fluid emissions directly from Solfatara and Pisciarelli, tracking the chemical composition and temperature of what's escaping from underground as a window into conditions far below the surface that no seismometer or GPS station can observe directly. Finally, it's worth introducing one more piece of vocabulary directly, because it's central to the specific scientific debate we'll examine in Part 3, the distinction between hydrothermal and magmatic unrest. Hydrothermal activity refers to the boiling, heating, and pressurized circulation of ordinary groundwater as it interacts with residual heat from the volcanic system Euro, a process that can genuinely produce real earthquakes, real ground deformation, and real gas emissions, without necessarily requiring any fresh magma to be involved at all. Magmatic activity, by contrast, specifically involves molten or partially molten rock itself moving, intruding, or degassing at depth. Distinguishing between these two possible drivers for any given episode of volcanic unrest is one of the most difficult and most consequential challenges in modern volcanology, Euro, and, as we'll see directly in the next section, it's a distinction genuinely still being actively debated for Campi Flegrei's current crisis specifically. With this foundational vocabulary now established Euro, what a caldera is and how it differs from a classic cone volcano, what bradyseism means and how long it's been documented at this specific site, INGV's formal alert level system, and the basic monitoring tools scientists use to track all of it Euro, we're ready to address the genuinely novel scientific claim at the center of this video's title. What does it actually mean for a volcano's unrest to follow a mathematical pattern researchers describe as almost unprecedented? And how much weight should that specific claim actually carry? That hidden mechanism is where we turn next. Here is the specific scientific claim at the center of this investigation, and it deserves to be explained with real precision, because both oversimplifying it and overselling it would misrepresent what's actually being argued. For decades, volcanologists studying escalating unrest at a caldera like this one have generally modeled that escalation using exponential growth Euro, a mathematical pattern where a quantity's rate of increase stays proportional to its current size. Exponential growth is genuinely unsustainable over infinite time in any real physical system, but it has a specific, important mathematical property worth understanding clearly. It doesn't, on its own, point toward any particular moment when something has to change. It simply describes unbounded, ever-accelerating growth without a built-in signal for when a system might reach some kind of breaking point. In April 2026, a team of researchers Euro, David Zaccagnino, Didier Sonnet, Antonio Giovanni Iacarino, and Matteo Picozzi, with institutional affiliations spanning the Southern University of Science and Technology in China, Italy's own INGV in Rome, and Naples' Federico II University Euro, posted a preprint arguing that Campi Flegrei's actual seismic and ground deformation data no longer fits that standard exponential pattern nearly as well as a different, more specific mathematical form, what's called a regularized finite time singularity, often abbreviated FTS. The distinction between these two patterns is genuinely important and worth walking through carefully rather than just naming. In ordinary exponential growth, the rate of acceleration itself stays constant, even as the underlying quantity grows. In a finite time singularity, the rate of acceleration is not constant Euro. It itself grows in proportion to how large the underlying quantity has already become. This produces a mathematical curve that doesn't simply accelerate, its acceleration accelerates, climbing toward a specific, calculable point in time Euro, denoted, in the researcher's own notation, as T sub c, or the critical time euro, at which the mathematical equation itself would, in the pure abstract, reach an undefined, infinite value. In any real physical system, of course, nothing actually reaches literal infinity. What a mathematical singularity like this one signals, instead, is that the underlying physical process the equation is describing cannot continue behaving the way it currently is all the way up to that euro. Something about the system's fundamental behavior has to change before, at, or very close to that calculated critical time. Applying this framework directly to Campi Flegrei, the research team analysed two independent, real datasets: continuous GNSS vertical displacement data from the Wright monitoring station discussed in Part 2, and the cumulative Benioff strain record built from the caldera's full earthquake catalogue. Using a formal statistical comparison method called the Akaike Information Criterion euro, a standard, widely accepted tool for judging which of two competing mathematical models better explains a given dataset euro, the researchers found that the finite time singularity model fit both of these independent datasets meaningfully better than the standard exponential alternative. Fitting both data streams forward, their analysis converges on a critical time window of approximately 2030 to 2034, alongside a specific quantitative projection. If the current pattern of magmatic volatile input into the system continues unchanged, cumulative uplift at the caldera's center could reach somewhere in the range of 4 meters by the early 2030s euro, up from the roughly 1.4 meters of uplift already recorded since the current episode began in 2005. This is a genuinely significant, carefully constructed piece of scientific analysis, and it deserves to be taken seriously on those terms. It's also essential, in the interest of the same rigor this channel has applied to every other emerging scientific claim it has covered, to be completely precise about what this specific finding does and does not establish. First, and most importantly, this is a single research team's preprint, posted to the open pre-publication repository arXiv, and as of this investigation's compilation, it has not yet completed formal peer review at any scientific journal. This isn't a minor technicality. Peer review exists specifically to catch methodological errors, challenge assumptions, and test whether a novel finding holds up under scrutiny from independent experts before it becomes part of the established scientific record euro. And a genuinely novel, high-stakes claim like this one, however carefully constructed, hasn't yet gone through that full process. Second, the specific mathematical technique involved euro, treating escalating geophysical unrest as a finite time singularity. In order to forecast a critical transition point, euro has a real, but historically mixed, track record in earth sciences specifically. A closely related approach, called the material failure forecast method, has been applied to volcanic eruption forecasting since the late 1980s, with a track record that includes genuine successes alongside notable failures and false alarms at various volcanoes worldwide. Didier Sornet himself, one of this preprint's co-authors, has spent decades developing and applying finite time singularity and related log periodic power law models to an unusually wide range of complex systems, euro, financial market bubbles, population growth, and various physical and social phenomena euro, with results that have themselves been the subject of genuine, ongoing scientific debate within those respective fields. None of this means the current Campi Flegrei analysis is wrong. It means this specific mathematical approach, applied to this specific volcanic system, is a genuinely novel test of a methodology that has not been definitively validated as a reliable forecasting tool in geophysics, and any responsible treatment of this finding needs to hold that context clearly in view. Third, and perhaps most important of all for correctly understanding this video's title, even taking the finite time singularity finding entirely at face value, it does not, on its own terms, predict an eruption. This deserves to be stated with the same clarity the research team itself used. Lead author David Zaccagnino has been explicit and direct about this exact point. Our paper identifies when the system is likely to reach a breaking point, but it cannot determine what will happen at that breaking point with the current data. A critical time horizon, in this specific mathematical framework, marks a point where the caldera's current pattern of behavior must resolve into something different euro, not a specific, predetermined outcome. That resolution could take several genuinely different forms: a full-scale eruption, a smaller, localized explosive or phreatic event driven by rapidly flashing groundwater into steam rather than fresh magma reaching the surface, a peak in the current uplift trend followed by renewed subsidence, the exact pattern this caldera has followed after each of its previous bradyseismic crises, discussed fully in Part 5, or simply a reorganization of the shallow hydrothermal and magmatic plumbing system beneath the caldera without any surface eruption at all. So here is the honest, carefully bounded version of this investigation's central scientific claim. A real, credentialed research team, using a real and statistically rigorous method, has found that Campi Flegrei's recent unrest fits an unusually specific and rare mathematical pattern better than the standard model volcanologists have generally used euro, a genuinely interesting, genuinely significant, and genuinely novel finding. That finding points toward a specific multi-year window in the early 2030s, when the caldera's current behavior pattern will very likely have to change in some way. It does not tell us, and its own authors are explicit that it cannot yet tell us what that change will actually look like euro, and as a single, not yet peer-reviewed preprint applying a historically contested methodology, it deserves to be treated as a genuinely important, actively developing scientific lid, not a settled, confirmed fact. With this careful, honest treatment of the finite time singularity claim now established, we can turn to the complete evidentiary record supporting the broader picture of accelerating unrest at Campi Flegrei euro, the actual earthquake statistics, the geochemical monitoring data, and the specific debate over whether this unrest is fundamentally hydrothermal or magmatic in origin. That comprehensive evidence base is where we turn next. Let's now walk through the complete evidentiary record underlying Campi Flegrei's current unrest euro, starting with the raw seismic statistics, moving through the geochemical monitoring data, and finishing with the genuinely unresolved scientific debate over what's actually driving all of it. Starting with seismicity itself. Campi Flegrei experienced what INGV's own monitoring characterizes as near-total seismic silence between 1985 and 2000 euro, a genuinely quiet, low-background period following the caldera's previous major unrest episode, discussed fully in Part 5. That silence has ended dramatically. Between 2021 and 2024 alone, INGV's Vesuvius Observatory recorded approximately 18,500 individual earthquakes in the region. In 2024 specifically, a record 6,740 earthquakes were catalogued in that single year euro, and the pace has continued intensifying through 2025 and into this year. Since early 2021, and accelerating further through 2024 into 2026, this seismicity has taken on a specific, distinctive character that seismologists describe as burst-like volcano-tectonic swarms euro sequences, where individual earthquakes occur in such rapid succession that distinguishing one event's seismic waveform from the next becomes genuinely difficult, both visually on a seismogram and mathematically, in automated earthquake cataloging systems. This specific pattern is consistent with pressurized fluid forcing its way through a sealed, relatively impermeable layer of rock. As gas or fluid pressure builds beneath this barrier, it can eventually exceed the rock's tensile strength, producing a sudden, concentrated burst of overlapping seismic events as the seal ruptures and pressure rapidly releases into the shallower crust above. This general style of seismicity has been documented as a precursor pattern, or an accompanying signal, during periods of genuine volcanic crisis at other volcanoes worldwide, which is part of why its emergence as the dominant seismic style at Campi Flegrei specifically has drawn sustained scientific attention. Now let's turn to the geochemical evidence. gathered through the direct field sampling INGV teams conduct at the Solfatara-Pisciarelli fumarole field introduced in Part 2. Several parameters here show sustained, long-term trends worth understanding individually. The ratio of nitrogen to helium in emitted gas has shown a sustained downward trend over roughly 25 years Euro, a pattern researchers associate with primitive magma degassing occurring under progressively lower confining pressure, consistent with a magmatic source migrating closer to the surface over time. Carbon dioxide flux from the fumarole field has escalated to figures reported as high as 3,000 tons per day Euro, a rate comparable to emission levels documented at other active volcanoes with genuinely open conduits connecting directly to a magma source, and one researchers argue would require a substantial, deep magmatic reservoir estimated at a confining pressure of at least 200 megapascals corresponding to a depth of roughly 8 kilometers to sustain over any extended period. The ratio of carbon monoxide to carbon dioxide Euro, a chemical proxy that's particularly sensitive to temperature, since carbon monoxide forms preferentially under hotter conditions Euro, has shown an accelerating upward trend over roughly 15 years, interpreted as evidence of sustained, intensifying heating within the shallow hydrothermal system. And fumarole temperatures at monitored sensor locations near Pisciarelli have been approaching 260 degrees Celsius, with specific sensors also recording ambient surface pooling of hydrothermal fluid at 97 degrees Celsius Euro figures that, taken together, point towards substantial ongoing thermal energy transfer from depth into the caldera's shallow subsurface. To formally connect these geochemical trends to the physical question of what's driving them, researchers have applied fluid dynamic simulations using TOUGH2 Euro, a well-established, widely used software platform for modeling the physics of heat and fluid transport through subsurface rock, applied across geothermal energy research and volcanic hazard studies alike. These simulations model the specific process of magmatic fluid injecting into the shallower, cooler hydrothermal system sitting above it, and they're used to estimate what's called the critical degassing pressure Euro, the specific pressure threshold at which deep magma would begin abruptly releasing a substantial pulse of superheated, water-saturated fluid directly into the overlying hydrothermal system, transferring a large quantity of thermal and mechanical energy into the surrounding rock, essentially all at once. Current modelling, according to the research reviewed for this investigation, suggests the system is approaching this threshold, though it's worth being direct that this specific projection carries its own layer of modelling uncertainty, exactly as any complex subsurface simulation does. This body of geochemical and simulation-based evidence feeds directly into the central, still unresolved scientific debate this investigation needs to present honestly, whether Campi Flegrei's current unrest is driven primarily by hydrothermal processes Euro, the boiling and pressurized circulation of ordinary groundwater, requiring no fresh magma involvement at all Euro, or by genuinely magmatic processes, meaning new or migrating molten rock at depth. This is not a settled question in the peer-reviewed literature, and different research groups examining the same underlying caldera have reached different emphases. The geochemical evidence discussed above Euro, the sustained gas ratio trends, the elevated CO2 flux, the accelerating carbon monoxide signature Euro, has led some recent multi-parametric analyses, integrating continuous geochemical sampling with the thermodynamic modelling discussed above, to favour an interpretation in which a magmatic source is actively driving the hydrothermal system's behaviour, rather than the hydrothermal system operating independently. It's worth stating plainly that this represents one credible scientific interpretation, built on real, multi-decade geochemical monitoring data Euro, not a unanimous scientific consensus, and this investigation should not present it as more settled than the underlying field itself currently treats it, bringing the seismic and geochemical evidence together with a separate, more recent line of statistical analysis. Researchers applying formal change point detection techniques Euro, statistical methods designed specifically to identify moments when a complex system's underlying behavior shifts from one regime to another Euro, have identified two distinct system-wide transitions in Campi Flegrei's combined seismic and geochemical dataset, occurring on November 30th, 2020 and April 1st, 2023. These identified transition dates align closely with the onset of the burst-like seismic swarm behavior and an accelerated phase of uplift discussed above, offering independent statistical corroboration that the caldera's chemical and physical evolution are genuinely linked rather than coincidentally overlapping trends. Finally, let's place this full evidentiary record directly alongside the earthquake statistics established in Part 1. The March 2025 earthquake referenced in regional damage assessments produced a peak ground acceleration exceeding 0.7 times the force of gravity euro, a genuinely severe, locally damaging level of shaking for a magnitude in the low to mid-4 range, reflecting how shallow this caldera's seismicity tends to be, with most significant events occurring at depths of only a few kilometers, meaning seismic energy has very little distance to attenuate before reaching the surface directly beneath the most densely populated parts of the caldera. This same shallow depth pattern held for Friday's record-breaking magnitude 4.7 event, recorded at a depth of roughly 3 kilometers. This complete evidentiary picture euro, thousands of catalogued earthquakes showing a documented shift toward burst-like swarm behavior, multiple independent geochemical trends pointing toward deep magmatic influence, formal statistical transition detection corroborating the timing of that shift, and a consistent pattern of shallow, locally severe seismicity euro sets up the essential next question this investigation needs to address. How does this current episode actually compare to Campi Flegrei's own deeper history, including previous crises that generated real alarm but did not, ultimately produce an eruption? That broader historical pattern is where we turn next. To properly judge how seriously to weigh everything established so far, we need to place Campi Flegrei's current crisis within its own much longer history euro, because this caldera has been here before, more than once, and understanding exactly how those earlier episodes unfolded is essential context this investigation cannot responsibly skip. Let's start with the deep, prehistoric baseline established briefly in Part 2. The Campanian ignimbrite eruption, roughly 39,000 years ago, remains the largest known explosive eruption in Europe over the past 200,000 years. Its true scale is illustrated by a specific, genuinely striking piece of research worth understanding in its proper context. In 2013, researchers examining volcanic ash deposits at a site called Erluia in southeastern Romania euro, more than 1,300 kilometers from Naples euro, found that ash from this eruption was deposited there at a thickness up to 10 times greater than existing computer models had predicted, based on standard estimates of how far and how thick an eruption of this scale should be able to spread ash. This finding, published in the peer-reviewed journal PLOSON, led researchers to conclude the eruption's true explosive magnitude had likely been underestimated. It's worth being direct about what this finding is and isn't evidence of. It's a genuinely significant, well-established piece of research about the scale of a catastrophic eruption that occurred 39,000 years ago euro, offering real insight into how powerful this caldera has proven capable of being in the deep past. It is not new evidence about the caldera's current, present-day state of unrest, and any framing that implies otherwise is misapplying a decade-old finding about prehistoric ash dispersal to a question about this decade's ongoing bradyseismic crisis. Now let's turn to something at least as important for properly calibrating this investigation's overall conclusions. Campi Flegrei's own, much more recent history of bradyseismic crises that generated real, serious public alarm euro and did not, in the end, produce an eruption. This caldera experienced significant unrest episodes in the 1950s and 1970s, and then, most dramatically, between 1982 and 1984. That earlier crisis remains the single closest comparison point available for understanding what a genuinely severe modern bradyseismic episode at this caldera can look like. Ground uplift during that period reached roughly 1.8 meters at Pozzuoli's center a euro, more than the total uplift recorded so far during the current post-2005 episode a euro, accompanied by intense seismic swarms and widespread structural damage. Approximately 40,000 residents were evacuated from Pozzuoli as a precautionary measure amid genuine fears that an eruption might follow. It did not. The uplift eventually peaked, then reversed into a period of subsidence, and the crisis gradually subsided without any eruption ever occurring. This 1982 to 1984 precedent matters enormously for how this investigation's central mathematical claim, discussed fully in Part 3, should actually be understood. One of the specific resolutions the finite time singularity model explicitly allows for a euro, stated directly by lead author Davide Zaccagnino himself a euro, is precisely this kind of outcome: a peak in the current accelerating trend, followed by deflation and a return toward quieter conditions, without any eruption occurring at all. Campi Flegrei has already demonstrated, within living memory, that it's fully capable of producing exactly that kind of resolution to a serious, multi-year bradyseismic crisis. At the same time, it would be equally irresponsible for this investigation to lean entirely on that reassuring precedent without also directly confronting the caldera's other historical lesson a euro, the one that gives Part 1's opening timeline its real weight, the 1538 eruption that produced Monte Nuovo. In the weeks immediately preceding that eruption, the ground beneath the eventual eruption site rose dramatically a euro, by some historical accounts, several meters in a matter of days a euro, accompanied by intensifying earthquake activity. And then, within a remarkably short window measured in days rather than months or years, that unrest culminated in an actual, if comparatively small, eruption, building the roughly 140-meter-tall cinder cone that still stands today. The lesson from 1538 isn't that this caldera reliably produces long, slow, multi-year build-ups before finally erupting. It's the opposite. It's genuinely capable, at least once in its documented history, of moving from serious unrest to an actual eruption within a window short enough that any evacuation plan built around a leisurely, months-long warning period could potentially fail to keep pace. Holding both of these precedents in view simultaneously a euro, 1982 to 1984's serious crisis that fully resolved without eruption, and 1538's serious crisis that resolved into an actual eruption within days a euro is not a contradiction. It's the single most important, most honest historical lesson this investigation can offer. Campi Flegrei's own deep and recent history genuinely supports both possible outcomes for its current unrest, and neither one can currently be ruled out based on the historical record alone. Now let's widen the lens one final time to the specific institutional response this pattern has already produced. Given both the caldera's own documented capacity for rapid escalation and the sheer scale of the population involved, Italian authorities have not waited for further certainty before acting. A peer-reviewed impact assessment published in 2023 in the journal Frontiers in Built Environment estimated that approximately 500,000 people would need to be evacuated from the highest risk zone during a formally declared alarm phase a euro, the red alert level introduced in Part 2. Civil defense authorities have conducted large-scale evacuation simulations, notably in the town of Monterosello, specifically to test and refine exactly this kind of mass displacement scenario in advance, rather than improvising one after the fact. Placing Friday's record-breaking earthquake and the finite time singularity analysis discussed throughout this investigation within this full historical arc produces a genuinely calibrated, two-sided conclusion. On one side, the current episode is real, well documented, and, by several independent measures a euro seismicity statistics, geochemical trends, and now this novel mathematical analysis a euro, shows genuine signs of continued acceleration rather than stabilization, distinguishing it in degree, if not necessarily in ultimate kind, from the caldera's prior crises. On the other side, This caldera has weathered comparably serious, comparably alarming episodes of unrest before, including one with greater total uplift than the current episode has yet produced, and resolved that prior crisis without an eruption. Both of these facts are true simultaneously, and any responsible treatment of this story needs to hold on to both rather than collapsing the narrative in either direction a euro toward false reassurance that this has happened before and nothing came of it, or toward false certainty that the mathematics now proves eruption is coming. With this full historical and comparative pattern now established, we need to turn to the genuinely forward-looking question this investigation has been building toward. What does the evidence actually suggest happens next? On what realistic timeline? And what specific developments should an informed viewer actually be watching for in the years ahead? That's where we turn next. Let's now turn to what the evidence actually says about what happens next, a euro, treating the finite time singularity window established in Part 3 with the same careful, bounded precision this investigation has applied throughout, rather than either dismissing it or overstating its certainty. Start with the single most important reframing this investigation can offer, because it directly shapes how everything else in this section should be understood. The 2030 to 2034 critical time window is not a predicted eruption date. It is a mathematically calculated point at which the current statistical pattern of accelerating unrest a euro, as measured through ground deformation and cumulative seismic strain, specifically a euro, cannot continue behaving exactly as it currently is. As established directly in Part 3, in Davide Zaccagnino's own words, the research explicitly cannot determine what actually happens at that transition point using currently available data. This leaves genuinely open at least 4 distinct categories of outcome, each with real historical or scientific precedent behind it. The first possible outcome is a full-scale magmatic eruption a euro, fresh magma reaching the surface directly, the outcome most people likely picture when they hear supervolcano. Given the caldera's documented total eruptive history discussed in Parts 2 and 5, this remains a genuine, serious possibility that Italian civil protection planning takes seriously, reflected directly in the scale of the evacuation planning discussed in Part 5. The second is a phoretic eruptioner, a euro, a steam-driven explosion triggered when groundwater flashes rapidly to vapor upon contact with ascending magmatic heat, without necessarily requiring fresh magma to reach the surface at all. This kind of event can occur with essentially no advance warning beyond the caldera's current baseline of unrest, and given the dense urbanization sitting directly atop the Solfatara and Pisciarelli fields discussed throughout this investigation, even a comparatively localized, non-magmatic steam explosion could produce genuinely severe casualties and infrastructure damage purely through the force of the blast itself. The third is the outcome Campi Flegrei has already demonstrated it's fully capable of producing within living memory. A peak in the current accelerating uplift trend, followed by renewed subsidence and a gradual return toward quieter background conditions a euro. Precisely the resolution of the 1980 2 to 1984 crisis discussed in Part 5, occurring without any eruption at all. And the fourth is a broader reorganization of the caldera's shallow magmatic and hydrothermal plumbing system a euro. A less dramatic, harder to observe directly outcome in which the underlying physical conditions driving the current unrest shift in some structural way, without producing either a clean return to quiet or a surface eruption in the near term. Given genuine, current scientific uncertainty about which of these 4 outcomes is actually most likely, what should an informed viewer actually watch for? Several concrete, checkable developments stand out directly from the evidence this investigation has assembled. First, and most directly connected to this investigation's central scientific claim, whether the finite time singularity model itself holds up as new seismic and deformation data continues accumulating through the remainder of 2026 and beyond, and whether the underlying preprint successfully completes formal peer review a euro, the single clearest institutional signal of whether this specific methodology withstands independent scientific scrutiny. The research team has stated its intention to develop a continuous forecasting system, updating its projections as new data arrives, which would itself represent a genuinely valuable, checkable resource for tracking this story going forward. Second, watch INGV's own formal alert level determination directly. As established in Part 2, Campi Flegrei has remained at yellow euro, attention euro, even through Friday's record-breaking earthquake. A shift to orange, pre-alarm, would represent the clearest, most institutionally significant signal available that Italian scientific authorities themselves have concluded conditions warrant active evacuation preparation, distinct from and considerably more consequential than any single earthquake magnitude record. It's worth noting directly that this specific threshold has become the subject of its own internal debate. Some scientists who find the finite time singularity evidence persuasive have argued publicly for a more cautious institutional posture, specifically noting that additional sublevels introduced within the yellow tier itself have, in practice, delayed the formal evacuation protocols specifically associated with a full orange designation. This is a genuine, live policy disagreement between reasonable, credentialed voices about how quickly a scientifically ambiguous situation should translate into mandatory public action euro. Not a settled question this investigation can resolve on its own, but one worth understanding as an active thread in how this story continues to unfold. Third, watch the geochemical trends established in Part 4 directly euro. Continued increases in CO2 flux, further shifts in the nitrogen to helium ratio, and fumarole temperatures approaching or exceeding the roughly 260 degrees Celsius figures already recorded. Sustained continuation or acceleration of these specific trends would offer independent, non-seismic corroboration of the broader pattern this investigation has documented, while a plateau or reversal in these same measurements would meaningfully complicate the picture of continued, unchecked acceleration. Fourth, and more broadly, whether the magmatic versus hydrothermal debate introduced in Part 4 moves toward a clearer scientific resolution, since the two competing explanations carry genuinely different implications for how quickly conditions could escalate toward either a phreatic or a fully magmatic event discussed above. It's worth closing this section with the same honest acknowledgement this investigation has returned to throughout. Genuine scientific disagreement exists here among credentialed, serious researchers about both the underlying cause of the current unrest and the appropriate institutional response to it. That disagreement is not a sign of confusion or incompetence within the scientific community monitoring this caldera. It's an accurate, honest reflection of how difficult this specific kind of forecasting problem genuinely is. Even with decades of continuous, sophisticated monitoring data available euro, a problem this investigation has tried to represent with the same precision the scientists studying it actually bring to their own work. With this forward-looking picture now fully established euro, 4 genuinely distinct possible outcomes, several concrete indicators worth tracking directly, and an honest accounting of real, ongoing scientific and institutional debate euro, we need to turn to the immediate human dimension of this story. Who actually lives inside this caldera right now? What Friday's earthquake specifically did to their community, and what it would actually take to keep them safe if the more severe scenarios this investigation has discussed were ever to materialize. That's where we turn next. Let's move now from forecasts and scientific debate to what's actually concretely at stake on the ground euro, because Campi Flegrei's unrest isn't an abstract mathematical curiosity. It's unfolding directly beneath one of the most densely populated volcanic risk zones on the planet. Start with the population figures themselves, because they establish the sheer scale of what's actually at stake here. Somewhere between 500,000 and 600,000 people live directly inside the caldera itself, across communities including Pozzuoli, Boccoli, and the western suburbs of Naples. The broader area considered at meaningful risk extends to more than 1.5 million people, and Campi Flegrei sits close enough to Vesuvius euro, monitored by the same INGV observatory, discussed in Part 2 Euro that some regional risk assessments describe a combined, overlapping hazard zone touching a population approaching 3 million people, making this one of the most consequential volcanic risk regions anywhere in the world. Now let's return directly to Friday's record-breaking earthquake and what it actually did to this specific community in concrete human terms. Beyond the 21+ injuries and roughly 250 immediate evacuations established in Part 1, the earthquake's damage extended into the physical fabric of daily life across Pozzuoli and the surrounding towns. Residential buildings sustained structural damage. Churches were among the buildings affected. Falling debris struck parked vehicles and rail infrastructure directly, and the closure of Pozzuoli's port cut off ferry access to Procida and Ischia at the height of summer tourist season Euro, a detail carrying real economic weight for a regional economy that depends heavily on that seasonal tourism. This single earthquake sits within a longer, cumulative pattern of structural damage this community has been absorbing for years, not months. Regional civil defense inspections conducted across the full span of this bradyseismic episode have identified thousands of structures no longer considered safe for habitation Euro, reporting on the cumulative toll places the figure at roughly 9,000 assessed structures, with somewhere in the range of 160 families having been formally, permanently relocated as a direct result. It's worth being appropriately careful about this specific cumulative figure. It reflects an ongoing, multi-year civil defense assessment process rather than a single, centrally published, internationally peer-reviewed count, and it should be understood as the kind of running regional tally that continues to be updated as inspections proceed, rather than a single, final, fully audited number. What makes this specific earthquake sequence genuinely difficult for the affected population, beyond any single event's direct damage, is precisely the cumulative, repeating nature of the crisis. This isn't a single earthquake a community absorbs once and then rebuilds from. It's a community absorbing a new record-breaking earthquake roughly once a year for 3 consecutive years running Euro 2024, 2025, and now 2026 Euro, each one adding fresh structural damage on top of buildings that, in many cases, hadn't fully recovered from the previous event. This compounding pattern, familiar from this channel's coverage of other regions facing repeated seismic disasters, carries its own distinct, corrosive form of hardship. Not the singular shock of one catastrophic event, but the slow, grinding erosion of housing stock, savings, and basic sense of stability across a community that keeps rebuilding only to be tested again. Now let's turn directly to the specific, severe hazard that anchors why this community's risk profile is genuinely different from most seismically active regions worldwide: the pyroclastic flow. Giovanni Macedonio, director of INGV's Naples Observatory, described this specific hazard to NPR in stark, direct terms. In the event of a genuine eruption, superheated volcanic material Euro, reaching temperatures around 1,472 degrees Fahrenheit, roughly 800 degrees Celsius Euro, could sweep across the surrounding terrain at speeds between 30 and 60 miles per hour. Macedonio's own assessment of what this means for anyone caught in its path was direct and unambiguous. There really are no countermeasures to protect yourself. This is precisely why Italian civil protection planning, discussed in Part 5, centers so heavily on evacuation rather than any form of in-place shelter or structural protection Euro for this specific hazard. Physical distance from the caldera before an eruption begins is, by Macedonio's own account, the only genuinely effective protective measure available. This is exactly why the evacuation planning figures introduced in Part 5 carry the weight they do. Moving roughly 500,000 people out of a densely built, geographically constrained coastal area Euro, bounded by the sea on one side and challenging terrain on others, threaded through by limited road and rail infrastructure, much of which, as Friday's earthquake demonstrated directly, is itself vulnerable to damage from the same seismic activity that would likely accompany any escalating crisis Euro represents. one of the most demanding disaster logistics challenges anywhere in modern Europe. The evacuation simulations conducted at Monterosello, referenced in Part 5, exist specifically to identify and address exactly these kinds of logistical bottlenecks in advance, rather than discovering them for the first time during an actual emergency. There's a final, genuinely important dimension to this story worth addressing directly: the emotional and psychological toll of living inside a genuinely uncertain, actively studied, repeatedly newsworthy volcanic risk zone. Residents of Pozzuoli and the surrounding towns are, by any reasonable account, following this story with the kind of close, personal attention this investigation's own audience is engaging with it from a distance a euro. Except for them, every new record-breaking earthquake, every new scientific paper, every shift in INGV's public communications carries direct, immediate, personal weight. That reality doesn't change any of the scientific conclusions this investigation has worked to establish carefully throughout, but it's worth naming directly because it's the human context every technical detail in this investigation ultimately exists within. What emerges from this real-world accounting, taken as a whole, is a picture of a genuinely severe, genuinely compounding, genuinely difficult situation for a very large population euro, one already producing real injuries, real displaced families, and real cumulative structural damage right now, in the present tense, entirely independent of whatever this caldera's longer-term mathematical trajectory ultimately turns out to mean. This is not a story that needs to wait for 2030 to matter. It already matters, directly, to more than 500,000 people today. This combination euro, a large, at-risk population, a documented, compounding pattern of real earthquake damage, an evacuation planning apparatus built specifically around one of the most severe, least survivable volcanic hazards that exists, and a community absorbing all of this, while genuine scientific uncertainty about the future continues playing out in real time euro, brings us to a necessary final task before this investigation can responsibly conclude: directly auditing the specific claims circulating about this story, including the claim embedded in this video's own title. That's where we turn next. Before reaching our conclusions, this investigation needs to address the specific claims circulating about Campi Flegrei directly euro, starting, as always, with the claim embedded in this video's own title. The first, and most important, misconception concerns the phrase physically impossible to break, and it deserves this investigation's most careful, precise treatment, because it sits directly on top of the central distinction this entire video has worked to establish. There are genuinely two different records referenced across this story, and conflating them is the single easiest way to misunderstand it. The first is Friday's earthquake euro, a real, literal, straightforward instrumental record, the strongest tremor recorded at Campi Flegrei since continuous monitoring began. That kind of record gets set and reset routinely at any actively monitored geological system as more data accumulates over time. There is nothing physically impossible about a magnitude 4.7 earthquake following a magnitude 4.61. The second, genuinely more unusual claim concerns the mathematical pattern of the caldera's broader unrest euro. The finding, established fully in Part 3, that its behavior fits a finite-time singularity model rather than the standard exponential pattern volcanologists have generally used. This is a real, statistically supported, genuinely novel finding. But breaks, the exponential model doesn't mean physics itself has been violated euro. It means one specific mathematical description of the data has been found to fit less well than a different, equally legitimate mathematical description. Describing this as physically impossible dramatically overstates what a change in statistical curve fitting actually represents, and it's language this investigation has deliberately avoided using in its own voice throughout, precisely because it isn't how the researchers who actually produced this finding describe their own work. The second misconception, closely related to the first, is the assumption that this mathematical finding constitutes proof that an eruption is coming. As established directly and repeatedly in Part 3, lead researcher David Zaccagnino has stated plainly that the model cannot determine what will happen at the identified critical transition point. As established fully in Part 6, at least 4 genuinely distinct outcomes remain consistent with the current evidence, only one of which is a full-scale eruption. Treating this finding as a confirmed eruption forecast misrepresents the researcher's own explicitly stated position. The third misconception concerns the scientific status of the finite time singularity finding itself, the assumption that because it's been covered in the press, it therefore represents settled, peer-reviewed scientific consensus. As established in Part 3, this remains a single research team's preprint, not yet through formal peer review, applying a specific mathematical methodology with a genuinely mixed historical track record in geophysics. This doesn't mean the finding is wrong, a euro. Genuinely important scientific discoveries routinely begin exactly this way, as a single team's preprint that later gets confirmed, refined, or occasionally overturned through the ordinary peer review process. It means this specific finding currently sits at an earlier, more provisional stage of scientific validation than a viewer encountering only the more dramatic press coverage might reasonably assume. The fourth misconception concerns the widely circulated finding that Campanian ignimbrite ash in Romania was found to be 10 times thicker than models predicted. As established directly in Part 5, this is real, legitimate, peer-reviewed research a euro, but it was published in 2013, and it describes the scale of an eruption that occurred approximately 39,000 years ago, presenting it, as some coverage of this story has, as though it were fresh evidence directly relevant to assessing the current 2026 Brady seismic crisis misapplies a genuinely significant but chronologically unrelated finding about prehistoric eruption dynamics to a question about present-day volcanic unrest. The fifth misconception, and one worth naming because it runs in the opposite direction from most of the others on this list, is the assumption that because this caldera has weathered serious unrest before without erupting a euro, most notably during the 1982 to 1984 crisis discussed fully in Part 5 a euro, the current episode is therefore nothing to take seriously. This would ignore genuine, real distinctions between the two episodes. The current crisis has already produced a documented shift toward burst-like seismic swarm behavior, multiple corroborating geochemical trends, and now a statistically supported finding of super-exponential acceleration that the 1982 to 1984 crisis, studied with considerably less sophisticated monitoring technology at the time, was never formally tested against. The 1982 to 1984 precedent is a genuine, important reason for caution against assuming eruption is inevitable a euro, not a reason to dismiss the current episode's genuine seriousness. The sixth misconception concerns the magmatic versus hydrothermal debate addressed directly in Part 4, the assumption that recent geochemical evidence has definitively settled this question in favor of a magmatic driver. As established there, this represents a credible, evidence-based interpretation favored by some recent multiparametric analyses a euro, not a unanimous scientific consensus, and this investigation has worked throughout to avoid presenting it with more certainty than the underlying field itself currently supports. The seventh misconception concerns INGV's current yellow alert level itself, the assumption that because the alert level hasn't changed despite Friday's record-breaking earthquake, authorities must be downplaying or ignoring the severity of the situation. As established in Part 6, this alert level framework is a formal, multi-tiered system specifically designed to distinguish heightened attention warranting closer monitoring from conditions warranting active evacuation preparation a euro, and the genuine internal debate discussed in Part 6 over whether sub-levels within the yellow tier appropriately balance caution against premature mass evacuation, reflect serious, good-faith scientific disagreement about exactly where that threshold should sit, not institutional complacency or a cover-up of the underlying data. The eighth and final misconception is the one this investigation has tried hardest to guard against throughout, treating genuinely uncertain as equivalent to either definitely nothing or definitely catastrophic. The honest, complete picture this investigation has assembled doesn't fit comfortably into either extreme. Campi Flegrei is a real caldera capable of a real, historically documented catastrophic eruption. It has also weathered comparably serious crises before without one. A credentialed research team has identified a genuinely novel, statistically supported mathematical pattern in its current behaviour euro. One whose implications, by that same team's own explicit account, remain honestly unresolved. Holding all of that together, without collapsing it into a simpler, more dramatic, or more falsely reassuring story, is exactly what this investigation has tried to do. What unites all 8 of these corrections is the same underlying pattern this channel has identified across every investigation of this kind. A genuinely significant, well-evidenced scientific story at real risk of distortion, specifically because its most dramatic-sounding elements, euro, impossible, obliterates the models, proves euro, travel further and faster than the careful, hedged language the actual researchers themselves use. The real story here doesn't need that inflation to matter. A record-breaking earthquake that injured more than 20 people last Friday, striking a caldera home to over 500,000 people, examined alongside a genuinely novel, still developing piece of mathematical research whose own authors are explicit about what it can't yet tell us, is already more than significant enough. With these misconceptions addressed directly, we can bring this investigation to its conclusion euro, including an honest accounting of exactly what remains unknown, as this dossier reaches its final form in the immediate aftermath of Friday's earthquake. This investigation closes in the immediate aftermath of a still unfolding event, not after one euro, which feels, in its own way, like an appropriate place for a story about Campi Flegrei to end, given how long this caldera's own story has been unfolding. As this dossier was compiled, building inspections across Pozzuoli and the surrounding towns were still underway following Friday's record-breaking earthquake, with the number of confirmed unsafe structures and displaced residents still expected to rise. The injury count euro at least 21, by some regional counts as high as 26 euro, should be treated as the most recent confirmed figure rather than a final one. If you're watching this after those specific numbers have settled, INGV's own public updates, alongside Italian Civil Protection's official communications, will tell you the real, final figures for Friday's earthquake far more reliably than this investigation, compiled in its immediate aftermath, ever could. The larger question this investigation has spent most of its runtime carefully bounding euro, what the 2030 to 2034 critical time window identified in the Zaccagnino, Sornet, Iacarino, and Picozzi preprint actually means euro will take considerably longer than a single news cycle to resolve, and this investigation wants to be completely honest about that timeline mismatch. Formal peer review of a finding this significant typically takes months, sometimes longer. Confirming or challenging its central mathematical claim will require watching how the caldera's actual seismic and deformation data behaves over the very years the model itself identifies as critical euro, meaning in the most literal sense that no one, including the researchers who produced this finding, will know with genuine confidence whether it held up until at least partway through the window it describes. What can be said with genuine confidence, regardless of how that specific mathematical question eventually resolves, is this. The underlying physical system driving this entire story hasn't gone anywhere, and doesn't depend on any single earthquake, any single preprint, or any single alert level determination. The warm, pressurized magmatic and hydrothermal system beneath Campi Flegrei has been shaping this specific stretch of Italian coastline for tens of thousands of years euro, visible in the boring marks on ancient Roman marble columns, in the yellow stone of Naples' oldest buildings, in a cinder cone that rose from nothing in a matter of days in 1538, and in a town centre that has been rising, slowly and then less slowly for more than 20 consecutive years since 2005. Whatever specific form this caldera's next chapter ultimately takes a euro, a peak and gradual deflation, echoing 1982 to 1984, a localized phreatic event, a genuine magmatic eruption, or some combination. This investigation hasn't fully anticipated a euro, that underlying system will still be there, driving it, regardless of which specific outcome the coming years actually bring. And regardless of how the mathematics eventually resolves, one thing is already true, confirmed, and worth sitting with honestly. More than 500,000 people are living, right now, inside one of the most carefully studied, most genuinely uncertain volcanic risk zones on Earth, Euro, absorbing a new record-breaking earthquake roughly once a year for 3 years running, watching scientists debate in real time whether their home's centuries-old pattern of slow, patient movement has finally shifted into something categorically different, and doing what people in genuinely uncertain situations everywhere have always had to do: rebuilding, adjusting, and continuing to live their lives inside a level of uncertainty most of this investigation's viewers, watching from somewhere far away, will likely never have to personally carry. Giovanni Macedonio's own words from Part 7 capture something this investigation's own careful mathematics ultimately can't. For the single most severe hazard this caldera is capable of producing, there really are no countermeasures to protect yourself once it actually begins a euro, which is exactly why the evacuation planning, the monitoring stations, the continuous GNSS data, and yes, the genuinely uncertain mathematical modelling this investigation has spent so much time carefully bounding, all exist for the same single reason: to buy the people living above this caldera as much real, usable warning as science can currently provide for a system that has already proven, at least once, in 1538, that it doesn't always give very much. Check INGV's own current alert level and Italian Civil Protection's latest updates for where this specific story actually stands by the time you're watching it. But whatever you find there, the deeper story this investigation set out to tell a euro about a caldera that has risen and fallen for millennia, a mathematical pattern that genuinely might be telling scientists something new, and 500,000 people living, patiently and uneasily, on top of the answer a euro was already true before Friday's earthquake broke its latest record, and will remain true regardless, of which specific window, if any, ultimately proves to be the one that mattered.